Hello and welcome to another AfterMaths episode of the Primary Maths Podcast, the show where we talk all things primary maths. With me, John Cripwell.
And me, Becky Brown.
Hello, Becky. How are you?
Hello, I'm well, thank you, John. I had a lovely Easter weekend, eaten lots of chocolate, had a few days off, and now, all refreshed and back to work. How are you?
Yeah, I'm good, thank you. It's nice to see you because it feels like I've not seen you in ages because you've been off this week. Thank you so much for coming back in time to record another podcast episode. It's just thinking back to Easter weekend, Becky. We're recording this on Thursday, the 9th of April, ready for it to go out on Friday, the 10th. So Easter Sunday was last weekend, and I have yet to eat any Easter eggs.
None at all. Why not?
Zero Easter eggs. I have had some little Easter cakes that somebody made, which were very nice. But I just haven't got around to it. I've been busy. They're sat there. I've got three. I've got 3 Easter eggs. But they remain untouched at the moment, which I think might be a record for me because normally, I mean, when I was a kid, they were definitely gone by like Easter Monday. Yeah.
Yeah, that's a long time, John. I mean, they would not have lasted that long in this house, I'm afraid.
My children's eggs get rationed out to them so that they don't scoff them all in one go. But they've not really had any yet either. They'll still be knocking around at Christmas at this rate.
Oh my goodness.
Yeah, but I hope everybody else has had lots of chocolate. If you celebrate Easter, or whether you do or you don't, it's a good week to make the most of all the chocolate that's about anyway, and all the sweet treats. And if you have been off school this last couple of weeks, we hope you've managed to have a nice rest and a nice break. And we're not going to talk too much about school today, are we, Becky?
No, we're going to try to avoid it for another week, John. Lots of maths, hopefully, but not too much school.
Absolutely. So this is the AfterMaths episode. If you're new here, welcome. This is the episode where Becky and I talk about maths, things generally, or things that just happen in life that might have a slightly loose connection with maths or with teaching or just with things that we find interesting, really. And then on Tuesdays, we have an interview episode during term time. So there will be a new interview episode out on Tuesday, which I'm very much looking forward to.
Yeah, it'd be nice to get back to the interviews again, John, as lovely as it has been talking about maths and all sorts of things this Easter.
Yeah, absolutely. Yeah. So we'll be joined by an expert guest on Tuesday, and then there'll be another AfterMaths episode next week. So if you haven't managed to do this yet, why not? Please do like and subscribe because it really helps us to continue to grow the podcast and the YouTube channel, and for lots of new people to find us. And the audience continues to grow, Becky, so thank you to everybody who is tuning in and downloading and listening to us. Now, for the first time, unbelievably, Becky, I think this is episode 66 of the Primary Maths Podcast. We're going to do a little bit of maths live because I came across an interesting phenomenon, really, this week. It was I don't know how I found it. It was somewhere on socials. I saw a video of somebody explaining this. Okay, it's something called Kaprekar's constant. Have you come across this at all before?
Is it K? Kaprekar with a K?
Yeah, Kaprekar with a K. Yes.
It feels like it does ring a bell, but I have no idea where from.
Okay, well, maybe it's just one of the conversations that you have with your mathematically minded husband to pass the time. Yeah. So Kaprekar's constant is 6174, 6174, which if you're watching on YouTube, I've done this on a whiteboard. Now, it's interesting for quite an unusual reason, really. I mean, 6174 doesn't sound particularly unusual, does it, or interesting? It's not a number that would jump out at you, but it has an unusual quality to it. So, Becky, can you give me a 4-digit number, please? Any 4-digit number, except that at least one of the digits has got to be different from the others.
Okay. Let's go with 9,000. 9,218.
9,218. So the first thing that we have to do is to rearrange these digits into an order so that they go from the largest digit to the shortest digit. So in this case, it will become 9821.
Yeah.
And then underneath that, disappearing on the screen there, thanks to my blue screen, we then have to reverse that underneath. So it becomes 1289. And then we subtract the smaller number that we've made from the larger number that we've made, so that we end up with, he says, trying to work quickly, 8,532.
Okay. Yeah.
Now we need to repeat the process again, putting them in the right order, sort of ascending order, which helpfully this number already is. So 8,532. Then underneath, same thing again. We'll put them, reverse that order, so 2,358.
Okay.
And again, subtract the smaller number from the larger number. So here we end up with 6,174, which is the Kepler's constant there that we mentioned before. Now, this will happen. You will always end up at 6,174 if you follow that procedure with any 4-digit number within 7 cycles of following that procedure.
Oh, I see. So it's not always after 2. Sometimes you might take
not
more.
always after 2.
Okay.
No, it's not always after 2. So you were very kind to me there, Becky, that you found a number that it worked after just 2 iterations of it. But yeah, you will always end up back at that. And I was just thinking, if I was teaching in, say, year 4, maybe, this would be a great little investigation that I could use to practice that repeated subtraction to get down to it. Now, that there isn't a nice, neat explanation for why this is. It's just a constant that you will find. It's a quirk of our base 10 system that these 4 digits will always come up if you follow this algorithm. But I just thought it was interesting. And the guy who found it was a guy called Kaprekar. I don't know what his first name is, I'm afraid. But he was a mathematician born in India in 1905. And I think he lived to about 1986. But he was a recreational mathematician. So his job was as a school teacher. He spent his whole career teaching in schools. But in his spare time, he liked to play with numbers. And he found this little quirk and had it named after him. And there are other Kaprekar constants as well. So there's a 3-digit one and a 2-digit one. But we went with the 4-digit one today. But again, I just thought that this was a fun little investigation. Can everybody, we're going to try and make this number, this Kaprekar's constant number, 6,174. Who can find a 4-digit number that gets there in one go? Who can find one that it takes all 7 goes and things?
A fantastic way to practice subtraction and ordering numbers in a meaningful way. You need to do it to get to the answer. Yeah, I love that.
Yeah, and I might argue that it's not necessarily always going to be intelligent practice in the in terms of the numbers. So I wouldn't be doing this until I was confident that the children were already familiar with. I'd already taught the skill of doing this and that they were comfortable with it. But if I just wanted them to get them to practice it, maybe we've not done it for a little while. Maybe I'm doing this in year 5. Actually, we've not really done column subtraction since the previous year. This I thought would be a fun way to. I mean, my interpretation of the word fun there, but a fun way to spend a little bit of time just doing some subtraction and a little investigation for them as well.
I love that. I love investigative maths anyway, but something that's just a bit more open. You think, well, which ones have 4 cycles, which ones have 3? Yeah, I love that. I might go and have a little play around with it myself later.
Yeah, it's interesting. And look out for some of the other Kaprekar constants as well. The 3-digit ones, 2-digit ones. I think there's a 5-digit one too.
Love it. Thanks, John. Some real maths.
Yeah, it's a first on this show. For the primary maths podcast, we tend to stay away from actually doing any maths, but that's, it's not always the easiest to follow along if you're listening in audio only, I appreciate. But go and have a look on the YouTube channel if you want to find that.
Easier to
and
follow
you can
than
see me on a
easier to
whiteboard.
things we talk about, John. Diving scores, for example.
Diving scores, yeah, straightforward. If you're interested in how diving scores are calculated at major international events like the Olympics, don't bother going back and listening to AfterMaths episode on it, because it was pretty much clear as mud, wasn't it, Becky? Despite
It
your
was.
best efforts, it's not your fault. It's
No,
the system.
yeah.
It's the system.
I have experienced some maths in my life this week, though, John. I haven't feel like I haven't spoken about maths for life for ages, although it's always coming up. Um, it has, of course, been bank holiday weekend. I was lucky enough to be away for the weekend, but the sun is shining. You start thinking of all the things you have to do, and we've been looking into getting our driveway. I mean, I use the term driveway very loosely. It's just a bit of land outside my front door, but we are looking to get it resurfaced. So interestingly, it's a very complicated shape. So it's almost like a triangle with the top removed, because that's where the road starts, and there's a little bit of a rectangle as well. It's quite complicated. And in getting quotes, everybody wanted to know what the size of the driveway was. So my husband and I went out with a tape measure, think
You
how
old romantics, you.
and
Eh?
I know, it's the best dates.
Yeah,
And it was just interesting because I mean, he is a secondary maths teacher, so he's very good at maths, thankfully. Um, but he very quickly, so we measured all the different sides and didn't do any angles. We just measured sides and different bits, and he very quickly came up with, well, it's about this. And I just said, how did you do it? And it was just interesting because what I would have done, this may not have been the right thing, but I was going to split it into a trapezium and a rectangle. I had to remind myself area of a trapezium, but I just
yeah.
about remembered that. And he had done two rectangles and a triangle, which mathematically probably much easier and much quicker. But it just led me to think actually, there's probably loads of ways you could split an odd shape into shapes that you easily recognize and can easily calculate the area. We did it two different ways. It's just one of those things, isn't it, where actually the way you do it doesn't really matter as long as you know what you're doing, can explain and prove that what you've done is a good estimate. It was just a good example of how we got to a similar answer. Luckily, they were very, very similar, but in two different ways. So that was my
Yeah, it's interesting, isn't it? Because, and again, we talk about why do we learn these things at school, and you have demonstrated that, one day you might buy a house with an unusually shaped drive, and you'll need to figure out what the area of that drive is. I suppose you could have got people to come out and measure up and give you quotes and things, couldn't you? But it's fun in a
yeah,
way, to puzzle these things out, and to find different ways of doing it as well. To me, that's the main reason why the area of a trapezium. Yes, we can look it up. We can ask ChatGPT to figure it out for us these days, I'm sure, or Claude or one of the other AIs. But unless you are aware of how to do that, it's that problem solving again, isn't it? Are you able to think through these things in a mathematical kind of way? And to me, that's the thing that we're trying to teach and kind of, uh,
yeah,
you know, give over to our pupils, is the ability to be able to think mathematically and to solve problems and to work with, the things in the world around us, which might, in this case, be a driveway
yeah.
that needs replacing.
And
What are you going for, Becky? Are you going for,
not
just a
sure.
bit of
I'm not sure
tarmac or?
something that is not going to allow any weeds to grow through it
Mm,
because I'm not a gardener, John, and I don't enjoy weeding the drive. So that is,
no, no. I'm sure there are
but
some people out there who do, but
oh
no, it's
yes,
not for
and
me. It's not for
there will be more maths involved, I'm sure, when we get quotes and when we start thinking about comparing different things. So it is a case of having the skills and being able to apply them, even if, like you say, you fed it into an AI. Um,
Yeah, you need to know what to ask it, don't you, before it can even do the calculations for
yeah,
you. So, although the AI might be able to remind you how to find the area of a trapezium, if you don't know that it's called a trapezium, that's going to be tricky, isn't it, to
yeah,
convey what you mean? So, um, I think that there are wonderful things that AI and other technology can do for us, but fundamentally, we need to be able to think as mathematicians, as problem solvers, to
yeah,
be successful human beings, I would suggest.
definitely.
And those are the skills that we should be, hoping that children leave us with in year 6. having developed them all the way through from nursery.
Yeah.
Just that curiosity and the way to ask questions and think about the world through a mathematical lens. So,
Yeah.
yeah, thanks for that, Becky.
Yeah. A little bit of massive life from my Easter weekend.
Now, I was very excited when you told me that you also had some etymology that we could
I
talk
did.
about today because I feel like we haven't done that for a while either. I don't want to say that you haven't been pulling your weight on this podcast for a while, Becky, but I can't remember the last time we did an
I
etymology. I'll be
know.
honest.
I know. Been collecting them all up, John. I was because I've had a break. I'm
We have a
back on. Yeah.
deluge of etymology. So etymology obviously is the meaning, that sort of the origins of the meanings of mathematical words. Etymology meets maths vocabulary, so we end up with etymology. Yeah. So what have you got for us this time then?
So we often, as I was thinking about, well, what could we explore that we haven't maybe talked about already? We've talked about some obvious ones, haven't we? And maybe some not so obvious ones linked to interviews or things we've been talking about. But we often talk about words that come from Greek or Latin roots, sometimes Arabic, but very rarely do we come across a word with a Norse root. So
Oh, no.
this time, instead of starting with the word, I specifically started with looking which maths words do we use today that come from Norse language. And a couple of good ones, actually, John. So the first one is the word odd. And I thought, actually, this is a good one to talk about. I loved this one. So the word odd can be tracked back to around 1300. As always, there's not clear records on this, John, but around about. And its first use mathematically, so obviously it has multiple meanings, the word odd, was in the late 14th century, around about then. And it comes from the Old Norse word oddie, which
As in
literally,
Bill.
I wish it was. I wish it
Somebody
was.
with a beard and a fascination for watching birds. No?
Yeah. Sadly
Slightly
not.
off the wall comedy in the 1970s and 80s. Sorry. Go on.
Memory unlocked. Yeah, so oddie, which literally meant a point or the tip of a blade. So if you imagine like a
Cool.
triangular top of a spear or a blade, and you're thinking about if you're grouping the corners, the three corners, you've got two together, and then you've got one sticking out the top. And so that one is the point sticking out at the end. Or if you had multiple odd numbers, of course, you could line them all up in twos and have one sticking out the top. So
So
that is why
the top pointy bit.
the top pointy bit. Yeah, the point.
Why don't we
Also,
have a word for that, Becky?
no.
It would be so useful day to day.
Yeah,
Yeah, it's a different time, wasn't it? Different
yeah,
time. You needed
absolutely.
to know where your oddie was. Yeah.
Um, my favourite bit, though, that they also used the word, and apologies for my Norse pronunciation, oddamada, which meant odd man, and it wasn't an odd man, as in a strange or peculiar
It was
person.
a pointy man? No?
Well, it was the third man who made the casting vote. So if there was a
Oh.
and it was equal, it was called the third man, even if it was more than a group of three. And it was the odd man who made the casting vote. So I loved that. I thought actually that's a really lovely way to describe odd as being the person left that might have that deciding vote.
Suddenly it all comes together. I can see where that came from now. Yeah.
Yeah.
Yeah,
So
lovely.
I then, of course, this is not a Norse from Norse, but I had to also then look into even, just even
Of
alphabet.
course. Yeah. I see what you
And the
did there.
word
Beautiful.
even comes from Old English, the Old English word even, and it wasn't used mathematically at all. It was used to mean, as we do now, level, flat, or smooth, an even surface, if you like. And interestingly, it was first used in a mathematical sense, or first recorded use in mathematical sense, in the 1550s. So slight
Oh.
discrepancy between odd and even mathematically. But yeah, so thinking of even as a level, like if you imagine a seesaw with equally weighted things on either side, even being they were the same, and then odd being that point at the top.
So
One,
odd was around much longer than even was.
yeah,
How strange.
I know.
I
I've always
suppose
had
if it wasn't odd, it was not odd.
not odd.
Yeah.
Yeah, yeah. So I quite liked that. And the only other, well, not the only other, but the other sort of main word that comes from Norse is the use of the word score to describe 20. I don't think we tend to do that these days.
Very
Some
rarely these days
hear
do I
it,
use
don't
the word score to,
on
assign
a
the number
quiz show
20.
on a quiz
Mm.
show maybe. Um, And that was
I'm going
so.
to start doing it again, though, Becky. I
Shall
might
we?
campaign for it to come back with Roman numerals in this new curriculum that we've got.
Yeah, we don't.
Dozen, score, and then we could bring in, some of the Cockney lingo, a monkey. What else have you got? It's a monkey 500 or 50?
I don't know, but yeah, there's lots.
A ton.
Actually, we could do that in a future AfterMaths. Look into different words for different
A
numbers.
ton's interesting, isn't it? Because if you think about a modern ton, a metric ton's 1,000 kilograms, whereas when we talk about a ton in terms of money, that's £100.
Yeah,
So yeah, somebody's
yeah.
not thought that through very carefully.
No, this is the problem: is they will probably all come from different roots, don't they? So they don't all fit together nicely. But this one particularly came from the Old Norse word "skor," spelled skor, meaning a mark or a notch or an incision. Now, it's probably used for counting large numbers. So if you were counting, they used an example when I was doing my internet-based research, that you might be counting a herd of passing sheep. I don't know why you would, but maybe
You can't get to more than 20 with them before you fall asleep, you see. So
yes,
that would
so
make
you
sense.
had to, every 20 you had to mark a little notch.
Mark it off and then nod off. Yeah.
And therefore score. Yeah. So
Yeah, beautiful.
and there were more, but those were the two that made most sense, I think, just to talk about. I thought it was nice to think about maybe when a word has come from somewhere different to the usual places we encounter etymology. So there you have it.
I like that. Thank you very much. Thank you very much. It's always nice to learn something new. And when I'm counting sheep tonight, as I'm trying to get to sleep, I will think of the Norsemen counting their 20 sheep at a time and marking them off as a score.
Yeah. There you go. And then, in future, we should look into those other words, John. You've opened up an idea for me there. What
Yes, well, I'm nothing if not helpful, Becky. I'll leave that in your court as the etymapsologist resident in this podcast. Thank you very much. I enjoyed that. I hope everybody else did. So I think, Becky, we're going to wrap that up here and have a nice short episode as our second Easter episode of the Easter period, the Easter holidays. But as I mentioned, we will be back on Tuesday with another podcast interview. Next Tuesday, I am joined by Dr. Paula Fieldhouse from Learning with Parents, and we're going to be talking a little bit about parents' involvement in children's early education, all the way through primary, really. But we're also going to be thinking about how we can engage those parents. And her specialism as well is financial literacy too. So there's some financial education discussion in there as well, which we know is going to be part of the, there's going to be a continued or growing focus in the new upcoming curriculum on financial education and financial literacy. So some interesting things to think about from that conversation too.
Great. Look forward to hearing that on Tuesday, John.
Absolutely. In the meantime, as I say, if you haven't already, please do give us a like, subscribe to us wherever you listen to your podcasts. We'd really love a review, wouldn't we, Becky? Particularly if it was a positive one, that'd be great. And if you have any other feedback, then just feel free to send it through to primarymathspodcast@twinkle.co.uk.
Yep. And if you have any comments or stories about your Easter, any maths of life you might have encountered, send that in too, and we can talk about it in next week's episode.
Absolutely. We always love hearing from you guys. Otherwise, we hope you have a lovely weekend, and we'll be back with you on Tuesday.
Thanks for joining us. See you next time.
Thanks a lot. Take care. Bye-bye.